Okay, our very last rule is going is going to be raising a quotient to a power. So once again, it's going to be very similar to what we did before. So for any real number a and b and any integer n, a over b to the power of n is just going to be a to the n, b to the n. However, if we raise it to a power of negative n, we can still use this rule, but there's a part of this will make it easier for us. If we just flip a and b, then we can make this a positive n. So that's just a thing that we can do. But let me focus on this rule first. So as an example, let's say I have 2 over x, and I raise that to the power of 5. Well, then we have 2 to the x, 2 to the x, 2 to the x. We saw something similar to this actually earlier. 2 to the x. So I got 5 times. We got 5 2's on top, and we have 5 x's on bottom. So here, just to explain why this works, let's say I had, we'll say 2 over x again, we'll use a smaller exponent, 2 over x to the power of negative 3. Well, I don't know how to necessarily write out that negative 3, but because we have that rule now that says that I can do this, one of the things that's going to happen is that these are going to flip places to make those positive exponents. So this is just x to the power of 3 over 2 to the power of 3. So what I could have done just initially is that when I had 2 to the x to the power of negative 3, is I could have just instantly flipped the fraction. So we're going to use what was called a reciprocal. So x over 2 to the power of positive 3. Okay. If you're not sure about the second part here, just ignore it. Just follow this rule and just simplify in the end. Okay, so we got a and b, so I'm going to do a 2 ways. Or I should say, so we'll just do ways. Way 1. So what I'm going to do is that I'm just going to take w to the power of 3, y to the negative 2, and this is all raised to the power of negative 4. I'm going to fix the way that looks. That was looking a little sloppy. Not that I'm necessarily doing better this time. Okay, power of negative 4. This is y, or sorry, w to the power of 3 to the power of negative 4. And this is y to the power of negative 2 to the power of negative 4. So this is y 3 times negative 4 is the power. And then this is w to the power of negative 2 times negative 4. So this is w to the power of negative 12. And this is y to the power of positive 8. So I'm going to bring this down here now. So we end up with 1 over y to the 8, w to the 12. So if you want with the other way you could have done this. So the other way that we were told is that I don't want that negative out front, or this negative exponent of negative 4. I just do a reciprocal of what's in the inside. So I put the y to the negative 2 on top and the w to the 3 on bottom, the power of positive 4. So now I'm going to get y to the negative 2, the power of 4. And I'm going to get 3 to the power, or sorry, w to the power of 3, the power of 4. Starting to get a little tired here. Y to the negative 2 times 4. And then w 3 times 4. So we get w to the minus 8, or sorry, let's try this again. Y to the minus 8 and w to the 12. This has to move down here, so we still end up with the same thing. hopefully I can do B all along like this. So B, we distribute, in this case, because we have two properties that we're looking at. Actually, let me get rid of A because I'm going to need all this room. So give you a second if you're looking at it. You need to pause. All right, so for B, first rule says that by quotient rule, I can do this. I have 3 a to the a cubed, b to the negative 4, and now that's all raised to the power of 5. Now I have 4b squared. I can raise that all to the power of 5. Now, by that rule I had with a power rule to a product, this is just 3 to the 5th, a cubed to the power of 5, b to the negative 4th, now to the power of 5, raised to the power of 5, 4 to the power of 5, and b squared to the power of 5. So what I could have done is just, actually because multiplication and division is going on here, that 5 could just distribute it everywhere right off the bat. I didn't have to do these 2 steps. I could have just done this. I just want to show you why I could do that though before I just started doing it. So anyway, 3 to the 5th. Just a minute, off the top of my head, I'm trying to get 3 to the 5th and it's not coming to me. We're in a couple hours here. 243 is 3 to the 5th. Then we have a to the power of 3 raised to the power of 5. So it's a to the power of 3 times 5. Then we have b to the power of negative 4, but that was raised to the power of 5. So it's negative 4 times 5. Now we have 4 to the power of 5, which is 1024. So just so you know, we cannot simplify this 243 over 1024. So those numbers are going to stay as is. And then we have b to the power of 2 raised to the power of 5, so b to the power of 2 times 5. So we have 243, and then we have a to the 15, b to the negative 20, over 1024 times b to the 10. And we're not quite done yet because by quotient rule, and you might have noticed another way I could have done this, but by quotient rule, I'm just following my rules here the way we have them. We have a b in the top and the b on the bottom, so I can subtract those powers. So this would be b to the negative 20 minus 10. So 243, a to the 15. Now we got b to the negative 30. And then once again, because that's a negative exponent, we move it to the bottom. So this is 243, a to the 15 over 1024, b to the positive 30. Okay. So some of you may have noticed that maybe it would just been easier just to switch this negative 20 down here first. It's up to you. I will pretty much, as long as your methods are mathematically sound and you are getting the correct answers, the methods that you use, I'm perfectly fine with, just as long as you're not making something up. So as long as you're following the math, we're good. All right, so our last bit here for this unit. So for worksheet number 11, just attempt these 3 problems. So pause for a moment. These are probably the toughest we're going to get. Just pause, go through it, and come back to the video and we'll go through it with you. All right, here we go. So like I said before, between that combination, your product rule and your quotient rule, we got, just because it's all multiplication. Now if there was addition, you couldn't do this, but we're dealing with all multiplication here. What I can do with this 3 is that I can just put it on everything. So that is going to be x cubed cubed, y to the negative fifth cubed, 6 cubed, z squared cubed. So we have 3 to the 3. So if we multiply those, that's x to the 9th. We have negative 5 raised to the 3. So we y to the negative 5 to 3. If we multiply those, that is negative 15. 6 to the power of 3. 6 times 6 is going to be 36 times 6 again. Ooh. Yeah, let me do this in my calculator. This is going to be 216. And then z to the power of 2 raised to the power of 3. So we multiply the 2 and the 3. That's going to be a power of 6. Now, I can't combine anything here because I just have an x and y and a z. I don't have any of the same variable, but I do have this negative 15 as an exponent. So the last thing I can do to make this simplified, x to the 9 over 216 z to the 6, and then we'll have y to the positive 15. All right, so for b, same thing. I can put this 2 on everything. So this is 8 squared, a cubed squared, b to the 5th squared, 12 squared, a squared squared, b to the 7th squared. So 8 squared is going to be 64. Then we have a to the power 3 raised to the power 2. So 3 times 2, that's going to be a to the 6th. B, the power of 5 to the 2. If we multiply those, we get a power of 10. We got 12 to the squared, so 244. So this one we can actually simplify, which is good too. We got a to the power 2 to the power of 2. So if we multiply that, that's a to the power 4. And then b to the power 7 to the power 2. If we multiply those powers, that's b to the 14. Let me see here. So 64 and 12, both of those are divisible by, we have an 8, 16. So 64 is just 16 times 4. And then 144 is going to be 16 times 9. So just, you know, we can cross out that 16. And we have a to the 6, b to the 10, a to the 4, b to the 14. So we have 4, and then we have 8 on top and bottom, so a to the 6 minus 4. Then we have b to the 10 minus 14. This is going to be over 9. So we are going to have 4a squared, b to the minus 4 over 9. We want positive exponents, so it's 4a squared, 9b to the positive 4th. All right, and then my last one I'll do in green. So C, so I'm going to give everything a negative power of 2. So that is an x to the negative 1 to the power of negative 2. That is y to the power 3 to the power of negative 2. 6 to the power of negative 2. Y to the 5th to the power of negative 2. So negative 1 times negative 2, this is going to be x squared. 3 times negative 2, that's going to be y to the negative 6. And then we have 6 to the negative 2. Y, 5 to the negative 2. So 5 times negative 2 is going to be y to the negative 10. So we have x So we have a y on the top and the bottom. We don't have another x, but we can combine the y's. Y to the negative 6 minus negative 10 from the bottom. And then we got 6 to the negative 2. I have x, y to the 4th, 6 to the negative 2. So then my very last part is I just need to move this up here because that's a negative power. So it'd be 6 to the positive 2, x, y to the 4th. Technically it's over 1. So if you divide by 1, we can kind of ignore that because it's just going to leave the number. So we have 6 squared, which is 36, x, y to the 4th. All right. So if you're working on this and you have any questions, feel free to ask me. Like I said, you can always go ask the instructor on any of these questions and they'll be sent to me. Usually this is the section I usually get the most questions on, just because it's a lot of rules to get through it and it just takes a little bit to get them memorized. Because like I said, it's just, I actually like rules of exponents because it's like a little puzzle to solve and all the all the little steps. But it's not so fun the first time you're trying to learn this. It takes a little bit for it to be fun. But like I said, if you're getting stuck, just send me a message because there's a lot of little things that people get stuck on here, just little mistakes you get stuck in your head. And I can easily just tell you, like how to get around that little mistake.